Welcome to Hot Topics. The video we're going to look at and review is based upon a dwelling unit, and we're going to look at the three groups of loads that a designer, installer, or inspector should look at and divide these loads up for inspection or installation, whatever may be the case. But before we get into the video, I would like to remind you, if you would please, to subscribe to our videos channel, and it sure would help us. And we'll keep these videos coming to you and try to keep you up with the latest as the code changes and so forth. But now notice when we review this particular illustration, we're applying the standard calculation. And of course, you know, Article 220, Parts 2 and 3 deal with a standard calculation. We'll later look at 220.82 and do the optional calculation. But notice we do need to divide these three loads, and that's mainly what we're kind of reviewing right now in this figure 22-1 in Stallcup's Electrical Design Book, Volume 2. And if you wish to purchase this book or download it and review it, just go to James Gray Stallcup and look at our website. You can also get it on our website by looking at grayboyincorporated.com and take a look at it and review it and see what you think. Now, notice the first group is the general lighting load that we want to look at. Now, that is 220.14J now, that where we would look at the general lighting load. And if we go, for example, if you have your code book handy, you know, we like to kind of go through that with you in Hot Topics. Go over to page 74. And on page 74, we would review 220.11 on the left-hand side of page 74. And notice how the code reads in 220.11. No, it's new material too inserted in here. And it talks about the floor area for each floor should be calculated from the outside dimensions of the building or the dwelling unit or other area involved. And then they kind of zero in for dwelling units. In the next sentence, it says, for dwelling units, the calculated floor area shall not include open porches, garages, unused or unfinished spaces not applicable and adopted for future use. So we kind of pick up then that we know we're going to use the square footage of the dwelling, basically. Now, we kind of review that, and then I like to go over to page 33, just so that we're on the same page. Not that we're not. But go over to page 33 of your code book if you want to. And on page 33, we want to look at a general purpose branch circuit. It's on the left-hand side of your page 33, and down a little over halfway. And we have branch circuit, general purpose. A branch circuit that supplies two or more receptacles or outlets for lighting and appliances. You know, where you might take a cord and plug connected air conditioner on an existing facility over in 440, starting about 440.62 in the code, and you could take 50% of a 20 amp circuit and have 10 amps on a general purpose circuit to feed that window unit where, you know, for health care and different reasons for older folks, and they have an existing type dwelling unit. And then, of course, you know, if you want a branch circuit appliance, that's listed there. And then your branch circuit individual. And basically, if you have an individual branch circuit, then the overcurrent device matches the conductor and the cord and plug connected load. Without, it's an air conditioner with an inrush current that you want to hold, and that load would appear in table 240.4G of the code, which we'll review. And then you have a multi-wire branch circuit, and notice that could be a hot and a neutral. In other words, ungrounded conductor and a neutral, or it could be three ungrounded conductor hots with a neutral, and that's considered a branch circuit. Well, a lot of folks thought, no, a branch circuit is just one hot and a neutral. Here it says no, it could be three hots and one neutral. It's when you use two neutrals, like a hot neutral. Now that's not a multi-wire circuit anymore. So that kind of defines your circuits, that we'd be looking at. Now, the next thing that we see in the illustration is that group load is the general lighting and receptacle loads. And how do you determine the number of receptacle outlets or outlets that you could put on a general purpose circuit? Well, now we're going to review that here in our next video, so kind of hang on, and we'll take a look at our next video concerning how we would determine the number of outlets allowed on a branch circuit in a dwelling unit, as well as a commercial and industrial circuit. Now let's review this figure 10-5A, and notice to the right, top of the illustration, we pick up commercial or industrial. We have a 15 amp circuit breaker. It could be 20 amp, but we're just using 15 for the illustration. A 15 amp branch circuit. So we take 120 volts, which is the voltage to ground on a 208 120 three-phase circuit, or single-phase circuit, either one. If it's a single phase, it's 240 120. But 120 into 180, that's 1.5. So we have 1.5 amp per outlet if they're non-continuous loaded outlets. So we could put 10 on this 15 amp circuit. Now, if it's a continuous load, I believe it's on page 30, let's see here, is it 33 that I want? Bear with me here a minute. It's page 34. Now going over to page 34 of your code book, on the left-hand side of the page, down at the very bottom, it's the last definition, continuous load, and that's any load that could operate for 3 hours or more, or you as the installer, or maybe even the designer of the circuit, has to estimate that. Could they possibly use those outlets, receptacle outlets that you see there, or any combination of outlets, lighting outlets and receptacle outlets? Could they use those outlets for 3 hours or more? Then you'd have to tack 125% onto that 1.5, and that'd give you 2.25 VA per outlet. And then, of course, that would reduce the number of outlets that basically you could put on that circuit. So keep that in mind as we go through this material. Now, let's look at the residential dwelling unit now to the left. And there's a 15 amp circuit. And notice the receptacle outlets on that circuit could be any number in accordance with the calculation of 220.14 I and J. Now, how did we come up with a 600 square foot? We will review that in our next video that comes up next, so keep watching. Now let's look at this video 10-5B, and it goes through the calculation procedures. Now notice the question is, how many general purpose receptacle outlets? Now remember, that's 2 or more receptacle outlets, or receptacle outlets and lighting outlets, or appliance outlets if they may be involved there, in a dwelling unit are permitted to be connected on a 15 amp 120 volt circuit in a dwelling type unit. Now we look at 210.11B as in boy, as well as 220.14 I and J is our key. Well, no, the 3 VA per square foot is no longer found in table 220.12. In the 2020 NEC, they relocated the 3 VA per square foot in the 220.14J section. And then notice you're just taking the volts times the device and divide it by the 3 VA per square foot. And the code tells us to do that. So we take the math and do it. That's where the 600 square foot comes from. So really your 220.14J as well as 210.11B, they work together, and we can put any number of circuits that we want, or I shouldn't say circuits, but number of outlets that we want on that 15 amp overcurrent device, as long as we don't exceed the 600 square foot. Now sometimes the cities says, no, we're not going to go along with that. We're going to allow maybe 10 outlets on a 20 amp circuit, or maybe even 13 on a 20 amp circuit, and we'll only allow 8 on a 15 amp circuit. So you have to check with the city to see if they have an ordinance regulating a circuitry loading, the number of outlets that you could put on a 15 amp circuit. But if not, then the step 2 rule here would be applicable. Now for commercial and industrial, below how many outlets could you put on a 15 amp circuit, 120 volt type circuit, and on a 15 amp circuit breaker? Then again, we'd look at 220.14, but don't look at J. It'd be 220.14I. Well, that's kind of a typo there. And 210.11B. Now, the square footage for the circuit, the device at 15 amps would be divided by 1.5 now, which would be, 120 volts divided into 180 would give us 1.5, so 180 VA per outlet. And when you took the 15 amps divided 1.5, then there's 10 outlets commercial. If now it's a non-continuous load like we looked at there on page 34, it's going to operate for less than 3 hours. If not, then we would take 125%, and that'd be 2.5 VA per outlet. Now we kind of pick up then that we'd have 10 outlets there, non-continuous duty, and that would be the number of circuits or the number of receptacles, outlets, or combination outlets, whatever, on a 15 amp circuit in accordance with 210.11A in the NEC.